made this possible. I understand how challenging it is to bring so many young people from so many schools all together in one place. So thank you very much for doing this. Okay, what my job, we have another school coming. So welcome, you guys. Hello. They're not listening to me. Hi.
Hi, bro.
We'll wait for the school bell as well. Okay, where are they going to sit? Now, I have one question for the organizers actually. Yesterday we had a young lady who had a second microphone because I like to ask you questions. Do we have somebody with a second microphone? We have one today, good. So, it's important that you're not frightened. Please don't be frightened if I ask you a question, okay? And at the end, I will be available as well to answer your questions. So it's very important that you think about questions that you want to ask me. And remember, no question is a silly question. Okay, no question is a silly question. So you can ask me and Ashana at the end of her presentation as well, whatever you like. It can be about particle physics, it can be about CERN, it can be about Switzerland. Is there snow there at the moment? Apparently yes. Okay, there's snow there. So my challenge this morning is to try to help you or guide you, help you to understand how CERN tries to investigate the mysteries of our universe. The mystery of our universe, okay? So the talk will cover a little bit of geography, a little bit of sociology, a little bit of politics, and answer the questions: what do we do, how do we do it, and why do we do it, okay? So we'll start off with a little bit of geography. The slide that you see at the moment is really a picture of where we come from. This is Geneva, okay? Which country is Geneva in? Just shout it out. Nobody here said anything. You guys know, okay? The guys in blue, I'm going to call you the blue guys, okay? The blue guys. Where is Geneva? I heard France over there. Okay. It's actually in Switzerland, okay? It's actually in Switzerland. But on this slide, you actually see two countries, Switzerland and France. And this white dotted line represents the border between France and Switzerland here, but actually they haven't put on the border at the other side because here is also France, okay? And where Ashana and I come from, where we work, this is CERN, and CERN spreads across the border. So when I go in the gate in the morning, because I live here, I go through a gate in France. But you can also, the main gate is actually in Switzerland. And when I move about in CERN, the site, I've not actually discovered how big this site is, but I'm told that 7,000 people go to school on this site. Well, at CERN, on any one particular day, there will be 5,000 people, so maybe it's roughly the same. But when I go across the site, I keep going into France, and I keep coming back into Switzerland, into France, back into Switzerland, and I don't cross an official border because CERN is international territory, okay? so we don't go across the border. So here is CERN, here is Geneva, here is France, and here is Switzerland. Okay? Here we have something called Lake Geneva. It's the biggest lake in Europe. It's also called Lac Le Mans. Now I have an interesting question for you. Does anybody here study French? Anybody study French? Put your hand up if you know French. Nobody knows French. Okay, so I have to be careful that we have some people on the front. But you guys in blue, you don't study French. I'm not really surprised. Okay. But the interesting thing is that if you work here at CERN, you actually have to be able to speak 2 languages. Okay? Can anybody guess what the 2 languages might be? German? No. French? Yes.
Swedish.
And what other language?
Swedish.
It's a language you all speak. At least I hope you understand it. Otherwise, I'm going home. What's the language? Good, thank you. Okay, so we speak English and French. Actually, English is the scientific working language. French, because many of the people who work here live around here. And for example, if you have something really heavy, like an LHC magnet, which I will talk about later, and you want it moved, then you probably have to ask in French for it to be moved. And this is quite challenging if you were born in England, like I was born in England, and when I got to CERN, I had studied French. I could read and write pretty well, but I couldn't speak. So it was very challenging to have to pick up a telephone and ask for somebody to come and move something. But gradually you learn. And the way that I learned actually was by playing football in a local Swiss football team. Okay? So that's just to tell you that I'm not just somebody who comes along and talks to children and students about science. I actually used to be a football player as well. And I was also a cricketer. Who plays cricket? Wow, I thought you might. India is really good at cricket, aren't you? Okay, so let's move on. Bit of geography. So, anybody know what these mountains are? Say again? The Alps, the young man in the front. Really good, well done. And what's that mountain? It's the highest mountain in Europe. Anybody know? It's white. So if it's white, you could think of a name for it. What name would you give it? No, the mountain. It's a white mountain, so why don't you call it the White Mountain? And that's exactly what they do, the French. They call it Mont Blanc. And Mont Blanc means the White Mountain. Okay? And it's 4,807 meters high, depending on how much snow is on the top. Okay? So it's quite high, but not as high as your mountains. And it's actually 100 kilometers from Geneva here. And you can drive there easily. And there's a tunnel right under that mountain, 12 kilometers long. But when you drive through that tunnel, can anybody possibly guess which country you emerge into?
France.
Good guess, but no. You've driven from Geneva through France, you come to that mountain, you drive through the tunnel. Which country? Have a guess.
Switzerland.
Switzerland, no. No? Where?
Ma'am is helping.
Okay, it's 5 letters. Well done. It's Italy. Okay, so it's Italy. You drive through that tunnel, you come out in Italy. So, when you're hungry at lunchtime, if you want to, you could drive to Italy and get some really good pasta and pizza, okay, for your lunch. I don't know whether you guys like pasta or pizza, I have no idea. But it's good when it's made in Italy, okay? So, Italy, France, Switzerland. If you continue in this direction, you come to some more countries. Can anybody guess what those countries might be? Yes. You weren't expecting to be asked these types of questions, were you? You were expecting to listen to somebody talking about physics and science. Well, I will. But right now, I'm talking about geography. I'm testing the geography department of your state. That's what I'm doing. Yeah? Germany, well done. Ja. So, das ist richtig. That's German. Well, that is right. That is correct. Germany, but not only Germany. Country next to Germany is called Austria. So you come to Austria, and a very tiny little country is called Liechtenstein as well. So why did I tell you that? It's because Geneva is actually very central in Europe. And if you take a plane from this airport, that's the airport, you take a plane and you fly in almost any direction, you can cover all of the countries of Europe in 3 hours. You fly 3 hours in any direction, you can get to Spain, you can get to Portugal, you can get to Finland, you can get to Sweden, you can get to the UK, you can get to Ireland, all of these countries in 3 hours. Okay? What else do we see on here? There's something that looks quite strange on here. There seems to be a yellow line. What's that? The Large Hadron Collider. The young man at the front is answering lots of questions. Well done, thank you. I'd like somebody else to answer as well though. So if you know the answer next time, just keep quiet for a minute, okay? And let somebody else have a go, okay? Otherwise, what happens is, they say, haha, we got a smart guy in the front, he's going to answer all the questions so we can go to sleep. Okay? We don't want that. All right? Yeah, the Large Hadron Collider. Now, does anybody know what the Large Hadron Collider is? Nobody has any idea what it is. No? Okay, another guy on the front. Well done. It's called a particle accelerator. Why do you think it's called a particle accelerator? Because it accelerates particles. Very good. An excellent answer. Now, what particles does it accelerate? Particles of dust? No. The guys who were here yesterday, can you not answer, please? Okay, I want the other guys to answer. What particles do you think it accelerates?
Protons and neutrons.
Protons and neutrons. Wow, that's a really interesting answer. Well done. The first answer is correct. Protons. It accelerates protons. But not neutrons. Not neutrons. It doesn't actually accelerate electrons either, but it could. And the difference between electrons and protons and neutrons are that, well, what is the difference between, I'll ask you, what's the difference between a proton, electron, and a neutron? What? We need the microphone now. Where's the microphone gone? My microphone person has gone to sleep. Okay? Come on, you have to work. If you have that in your hand, you have to work. So, who's going to answer?
Positive and negative
Positive
charge.
and...
Positive charge and negative charge.
Good. The word that is important is charge, that's right. So, protons and electrons are charged, and neutrons are not charged. So that's a big difference for an accelerator, okay? So in fact, the LHC actually accelerates protons, and it uses the fact that they are charged. The accelerator that was in the same place as the LHC in the 90s, in the 1990s, that accelerated electrons, okay? But today it's protons, and we use the fact that they are charged. Now, I wasn't going to do this now, but we can do it now because we've talked about it. How on earth can you, well, first of all, where do you get protons from? Do you ring up Amazon.com and you say, please send me a box of protons? Can you do that? Well, you can't actually do that, but you can ask them to send you, or maybe not Amazon, but Carbagas, you can ask them to send you something which is made of protons and something else. What do you think that might be? Guy on the front said hydrogen, okay? What is hydrogen made of? Proton and an electron. So it's the simplest atom.
Very smart.
All you have to do, not so easy, but all you have to do is you have to break the atom into a proton and an electron. Okay? So then you say, okay, we don't need the electrons. So we can throw them away or let them wander off and disappear. Okay? But we have a proton now, and what we're saying is that the Large Hadron Collider accelerates protons. What does accelerate mean? Change what? So you accelerate it like a car, you make it go faster. And by making it go faster, you give it a lot of energy, which is very important for what comes next, okay? But the interesting question is, how on earth do we make a proton move? Does anybody know? No? So I need some help. I need this young man to come here. Come, yeah. Just stand here a minute. Hey. Does that mean it's still working? Okay, I'm going to give him the microphone and the point and this. Okay? Because I need to show you something. Now, I'm going to be a donkey. Okay? I'm going to be a donkey. And I want you to tell me how you can make a donkey move.
I guess by pushing it or something. Okay, he is a donkey.
How you make donkey move?
Okay, can anyone tell me how you're going to make him move?
Give him something to eat. You got some answers. Can you say what you got?
By reading on his back.
Beating.
Beating on your back, like
Kicking.
patting you.
I don't like that. You got a better answer? What? Excuse me.
Show some food.
Okay, we got the we have another group.
By applying some energy,
What was that?
By applying
Well,
some energy.
Applying some energy.
I'm just waiting for these people to find a seat. Can they find a
How
seat?
lovely.
I don't think it really matters if they're sitting in their schools.
Whole line of chairs here. Here, beta,
Come to the front, it's okay.
Come here. Come here.
ನಿಂತ್ಕೊಳುತ್ತದ ಬೀಳಲ್ಲ ಇದೇ ಬೀಳಲ್ಲ.
All right.
ಅವನ ಜೊತೆಗಿದೆ ಅವತ್ತು.
So welcome. I haven't said much yet, actually, so you haven't missed too much. Okay, so the two answers were right. In fact, so you could, to accelerate me, if I'm a donkey, you can put a lion behind me, or if you really want, and I don't want you to, but you could hit me, okay? All right? And somebody who was more kind said you could put a carrot in front of me, okay? And then I would move, probably, if I'm a donkey. Now, what is the carrot and what is the lion for a proton?
Accelerator.
An accelerator, yes, but what is the principle of acceleration of a charged particle? Oh, it's the same young guy.
The lion might be a proton cause it will repel it, and the carrot might be an electron cause it's negatively charged.
Okay, well done, well done. In fact, we talk about electric fields, actually. So you accelerate using an electric field, and if you put a negative charge and negative field in front of a proton, it will go towards it, or you can push it with a positive field. And in fact, we use both of those principles at CERN to accelerate protons. Okay? So, we haven't got very far. We've only got to slide 1, but we've talked about things I would have talked later, which is good. So we have a particle accelerator called the Large Hadron Collider. Why do we call it large? Because it's big, it's 27 kilometers in circumference, okay? 27 kilometers in circumference. Why do we call it a collider? Because we collide protons in it. We send protons round one way and protons round the other way, and we make them collide at various places around the ring, which are called the experiments. That's where we do the experiments. So we collide the particles. Why do we call it a Hadron Collider? Simply because protons are a member of a family which is called hadrons. Okay? So, Large Hadron Collider. Now, I'm going to be a little bit picky with you now. I'm going to ask you, is that really the Large Hadron Collider? Am I telling you the truth? If I'm asking you, maybe the obvious answer isn't right. So what is the obvious answer? You've only got two possibilities. Those of you who think it is the Large Hadron Collider, put your hand up. So you all think I'm not telling the truth. Those who think it's not the Large Hadron Collider, put your hand up. So there are a lot of people that don't think, all right? The ones who put their hand up and said no, why did you do that? Why did you do it? Just because you wanted to say no? Yeah? Just because you wanted to say no? No. Okay. You're still a bit shy. Actually, it's the footprint, if you like, of the Large Hadron Collider on the countryside. Okay? Because the Large Hadron Collider lives 100 meters below the ground. So this is only a representation of the accelerator. If I drive home, I cross the Large Hadron Collider, but I don't see anything that would give me a clue that it was there. Okay? Because everything is underground. The accelerator and the experiments. Okay? Now you can think, I give you this as a challenge. I don't want you to answer me now, but you can come up at the end and tell me the answer if you know it. Why do we put it underground? To put it underground, you have to build a big tunnel, and you have to build big caverns where you can put the equipment. And that's expensive to do that. It's not so easy. So why do we do it? Okay? So that's a question you can answer at the end. So let's move on. Let me check if this actually works. Wow, it works. Okay, so this is somewhere in Europe. We're going to do a bit of history now, a bit of sociology. This is somewhere in Europe in 1945. None of you speak French, okay, so I'm not going to ask you to translate it. I will translate it for you. This says 1945 Europe, after two devastating wars in less than 30 years, somewhere in Europe. And what happened was that researchers, scientists, left Europe, were leaving Europe to go to the USA. It was called the brain drain, okay? And some very smart guys, very smart physicists, scientists, said this is not good, this is not good. And they proposed to an organization called UNESCO that there should be a laboratory built in Europe which would attract these people to stay in Europe and do their research in Europe. So that was called the brain drain, 1949. And in 1954, CERN was founded, 12 European states, and today we have 23 member states and some associate members and other people associated with CERN. Notice India is there. India is not yet a full member of CERN, but it is an associate member. Okay? So all of these countries are members of CERN, which means they pay the budget of CERN. And I'll tell you what the budget is in a minute. But what's the algorithm? How do you decide who pays what? Okay? Can anybody guess if you have a big pie, and you slice the pie up, and you give the biggest piece to the country that pays the most, which do you think would be the country which would pay the most of these countries? Nobody want to guess? Would it be Hungary? No. Would it be France? Possibly. Would it be Germany? Yes, because Germany is the richest of these countries as measured by gross domestic product. Okay, GDP. Who knows what GDP is? Put your hand up. Nobody knows what GDP is. Yes, some guys at the front know what GDP is. It's a measure of the country's wealth. Okay? So they all pay a certain amount of money. Little Hungary doesn't pay very much, but the interesting thing is they all have one vote on the CERN highest body that makes decisions at CERN, which is called the Council. All of these guys have one vote. So it's a very democratic organization, okay? India also pays money to CERN, but not as much as if it was a member state, not yet, okay? So we have some guys at the bottom that don't pay any money at all, but they do contribute to CERN's research. Japan, Russia, United States, they're very big countries, they're very rich. They don't pay to the budget of CERN, which means they don't vote, but they do pay to the experiments in which they participate. That's how they participate in CERN. But the important thing is they don't vote. Now, what is the budget of CERN? Well, it's actually about 1.3 billion Swiss francs or dollars. Now, I have no idea how many rupees that is, but you can calculate it, okay? Is that a lot of money? Who thinks that's a lot of money? Okay? Who thinks that's not a lot of money? Okay, we've still got half of the audience who don't think, but I'm going to get them thinking by the end, hopefully. Okay, so how can we measure it? How can we measure it? $1.3 billion, some big number of rupees. Who knows Mark Zuckerberg? More of you know Mark Zuckerberg. Personally? Not yet. You might do. Okay? Well, do you know that he paid $19 billion for the WhatsApp application that you use on your telephone? $19 billion. For me, this is hallucinatory. Okay? But that's the world today. What's a better example? I didn't talk about it, but I am associated, of course, with CERN and my old university, the University of Birmingham. The budget of the University of Birmingham, a middle-sized university in the UK, is actually that. So that's a much better comparison because the University of Birmingham is an academic institution, CERN is an academic institution as well, okay? So that's more interesting comparison. What I've also got on here is who works at CERN. Well, we have 2,500 members of staff. That's much less than the number of students in this school. And they actually provide the facility. They help to make the accelerator work, they run the experiments, but the people who do the experiments at CERN are basically these guys, 13,000 scientific users from all over the world. So that's like 2 times the number of students who are in this school. So 13,000 scientists might seem to be a big number, but compared to the number of students in this school, it's not so big, which is something that I've learned this week, okay? Okay, so there we are. Where do they come from, all of these scientific users? Well, in 2017, they came from all of these different countries. So these are the member states here. We have some associate members, India, 336 in 2017. We have all of these guys here who come from the rest of the world, the red countries. They don't contribute to the budget of CERN. They're not member states of CERN, so they can't vote, but they participate in the experiments, okay? And they participate with money, material, or manpower. Those 3 things, you can participate. Why not so many from Africa? Can anybody guess why not so many from Africa? Well, unfortunately, unlike India, the African subcontinent does not have an educational system that will produce today the technical, scientific, engineering skills that would benefit from being associated and working with CERN. India definitely has all of that, okay? So that's why India is a precious member or associate member of CERN, okay? So that's where everybody comes from. Now, interesting question, which I didn't say yesterday, which I should have said. Big important question now. Who do all of these people work for? Who do they work for? Do they work for the member states who pay them money to operate CERN? Yes or no? Well, obviously, yes, but they work for somebody else as well. Do you know? Because you're smiling as if you know. Thank you for smiling anyway. Anybody know? Who could they possibly work for? All these people. They actually work for humanity. What does that mean? It means that all of the work that is done at CERN, all of the science that we do, is actually published and made freely available to the whole world for nothing. Thank you. It's not me who decided that. It was decided in 1954. But it's true, okay? It's true. You don't have to be associated with CERN to get access to the results of the research that we do. And we'll talk about what we do in a few minutes, okay? So that's a big important message to take home with you. This organization, CERN, works for you, works for everybody in the world. We have no secrets, at least none that I know about. Sorry, that's a joke. Okay, no, we have no secrets. We tell everybody. Okay, so what do we do? What are our missions? What are the strategic missions of CERN? Well, they're written here, but we'll go through them one by one. If I were to ask you to write down what we actually do, I hope that some of you at least would write down that we do fundamental research trying to understand the mysteries of our universe by asking some very fundamental questions that we'll come to in a minute. And so this is the scientific research that we do. And this is what is published. The results are published for everybody. Everybody. Now, to do that though, I mean, these experiments that we do at CERN and the accelerator we built, they were thought about 20, 30 years ago. But when we thought about doing this, the technology to do it did not exist. So what did we do? Well, obviously, we went to sleep 25 years. Oh, now we can do it. Did we do that? Yes? Who thinks yes? The young lady thinks yes. Who thinks no? Are we getting more people thinking? Maybe we're getting more people thinking, okay? When I ask you this question, I want you to tell me, okay? So who thinks yes? Who thinks no? Good. We didn't go to sleep. What we did was we tried to invent the technology. And when you invent technology, this becomes interesting, not only for the main purpose that you're doing it, which is to build a particle accelerator, etc., it becomes available to other people. And notably, now, before I say this, I have to talk about something else. So we've talked about a particle accelerator. We accelerate particles to high energy, we smash them together. Okay? We smash them together and we look as to what is produced and what happens when we smash them together. So we use another instrument to do the looking, and it's called a detector. We call it a detector, okay? But that's not a word that people understand what it means. So there's another word which is much easier. It has 6 letters, and it begins with C. Can anybody answer what that word is? Tell me what that word is. 6 letters, begins with C, and ends with A, and has an M in the middle. What? Camera. Very good. Well done. Camera. So what we do is we take the protons, accelerate them to very high energies, we smash them together, and we take a photograph of what happens. Okay? And we do this many times. Okay? So we have 2 big instruments, accelerators and detectors and cameras. And you say, well, how can they possibly be used outside? And the answer is, they are used in medicine. Medicine. So the camera, very, very similar to the cameras that we use, and Ashana is going to talk about this, are used in medicine to look inside your body and find out if you have something that's not good there, and to locate it very precisely. Because if we can do that, we can actually kill the thing that we don't like with a particle accelerator. So you probably didn't know this, not many people do, but the big machines that we use for doing particle physics are used in medicine extensively all around the world, including India. Definitely the cameras, not so many countries have the accelerators doing this job yet. Okay? So you can help India get 1 or 2 of these, actually, if you want to. So, and in addition to that, we have things like the World Wide Web. Do you use the World Wide Web? Who uses the World Wide Web? I don't believe you. Many more of you. Who uses the World Wide Web and the Internet? Huh? Haha, that's more people. Okay, now I ask you a question. An additional question.